So this is G484 homework booklet question 11. A part 1 is a simple statement of Boyle's law. You'll find a statement of that on your definitions cards. So what we're after is pressure is inversely proportional to volume, for a fixed mass of gas at a constant temperature. So the inversely proportional to volume for the first mark, fixed mass of gas at constant temperature for the second mark. There are other ways that they'd accepted expressing the inversely proportional to PV is constant is the most obvious one. We're then asked to draw a couple of graphs for a gas which obeys Boyle's law sketch. On the first diagram, a graph of pressure against volume. So we did plot this one, and you should be used to that shape, 1 upon x shape. The graph should be approaching the axes but not touching them. Both directions, approaching the axes and not touching them. What you need to be careful of when you're sketching these is that you don't curl back and actually have it going up or backwards either side. Just be careful that it's heading towards those axes and not going beyond them. And because it's inversely proportional for the second graph, P is inversely proportional to 1 upon V. That means that P against 1 upon V should be a straight line through the origin, just because we've got that proportionality. Moving on then to part B, we've got a cylinder of fixed volume filled with nitrogen gas at that pressure and that temperature. We've got the molar mass. It's interesting here that they've given you some information at the beginning, so you know that everywhere within part 1 and part 2 of B you might need to use that data. Calculate the number of moles of nitrogen in the cylinder. Fairly straightforward use of PV equals nRT. We should get 8.36 moles. You can obviously read the detail of my sum I've done there. One thing you do need to be careful of is, as always, that we need to be using absolute temperature, so not 15 degrees C, but 15 plus 273 gives me 288. And they're quite explicit on the mark scheme that if you use 15 degrees there, you get exactly no marks. So after 100 days, the pressure has fallen, and the pressure has fallen to 4.5 times 10 to the 5. The same temperature because of leakage. Calculate the mass of nitrogen that has escaped. One of these ones where we need to be very careful to read this. Calculate the mass of nitrogen that has escaped. So what we need to do is to find out how many moles we've got now. So that's a straight repeat of the calculation there that we did in part 1, but on the new pressure. That gets us that the number of moles is 7.52. That's the first C mark. Now, it was about the amount that's escaped, so I'm not interested in the mass I've now got. I'm not interested in the mass I did have. I want to know the mass that I've lost. You could work out the mass of that number of moles and the mass of that number of moles and subtract them. Perhaps makes most sense to work out how many moles we've lost by simply subtracting the answer from part 1. Taking the answer to part 1 and subtracting this 7.52. That's the number of moles we've got. Then all we've got to do is a straightforward mass is number of moles multiplied by the molar mass, and that gets us to the 0.023 kilograms. If you're clever, you might spot that the pressure has dropped by 1/10. Therefore, the moles I have lost is 1/10 of the moles I started with. Therefore, the mass I've lost is that. So, in fact, this moles lost figure, you'll notice, is 1/10 of the number of moles I had to start with. That's perhaps a slightly easier way to do it. Quite a cunning way of spotting that. So read the question carefully. Quite a lot to do for 3 marks there. Not a lot of space to do it, but I think really that's because they're not giving you a great deal of credit for that, because they've already credited your ability to do it in part 1. So that was G484 homework booklet question 11.